Welcome back, everyone. Today, what we're going to be doing is we're going to be finishing up our three-part series on this particular CodeForces round 355. And we're going to be talking about the part B problem, or the B problem. And this particular problem was something that I solved very, very quickly, and then realized that it was completely wrong once I started seeing that other people's code started getting hacked. And that's the process of when they give the test data out, that you can get an accepted, but you didn't test all the test data, so that you could possibly still have the wrong answer, but you generally have the right idea. So what we're going to do is we're going to take a look at this problem and see, hey, what could actually go wrong? So this particular problem, we are going to be having Vanya is back again, but she is using a vertical food processor. And in this particular processor, she has these potatoes. And she's going to be taking in potatoes, and she has this food processor which has a height of h, so it's however big it is. And we're guaranteed that there are no tomatoes bigger that won't fit in the food processor. So if it holds 6, then we're going to have to hold 6. We'll have to do 6 as well. Then what we're going to be doing is, and then the food processor every second can only process K amounts of food. And K is always going to be less than the height or equal to the height. So we're never going to always get negatives. And that's how we're going to be doing it. Now, my very first submission to this particular problem, and I'll show you guys this real quick, I got a time limit exceeded, which means I actually did this particular process one step at a time. I loaded a potato up, I crushed it a little bit, I checked to see if I could add the second potato in. I couldn't, so I smashed it again, see if I could put another tomato on it. Which, if I look at it, I'll just skip through the code for a second because we'll talk about it. It gets the correct answer. However, when we get up to this large amounts of data here, and we're only processing 6 units every single time, it gets a little time consuming, and unfortunately this could not run within the time limit. So I had to figure out a way to make it run faster. Now, you're going to notice I also have another skipped one on here, because I did fix that problem within 10 minutes. But if you notice, I had to resubmit it up here, and I'll show you guys why during that when I'm actually coding it up. So let's go to B real quick. I did not create a B problem, so this is from the last video. So let's create B real quick. And again, I'm going to create my scanner. So we're going to do scanner scan equals new scanner system.n. Boom. And then I need to take a look at a few things. What are we taking things in? We're doing n, h, and k. They're all integers, so I can read all those in there at once. So I have an int called n, so we'll call that scan.nextInt. Then I have int. Next one comes in h, so scan.nextInt, and int.k equals scan.nextInt. Now I will tell you, this gets a little confusing. Look at this order and then compare it to how they describe the variables or the bounds of the variables. They're not the same order. So be very careful. This is a very easy way to trick yourself up. In fact, I did have some students that were working on this particular problem, but got a couple wrong answers because they screwed up on the order of reading H and K. So be very careful about that. Okay, so I read in the top line. Now I definitely know that we need stuff from the bottom. So what I'm going to do is I'm going to create an integer array. I'm going to call it input. I should call it potatoes, but I'll call it input. New integers, and then and it needs to be size n because that's how many we're going to have. So we're going to load up our potatoes in So we have, let's put some more stuff in here. So input 0, oops, not 0, but I, and we're just going to scan everything in. So now I don't have to really worry about scanner anymore. Everything that I'm going to be using has been inputted into the program. So now I need to really look at this and say, okay, what do I really need to be doing? So I'm going to create another variable called int, or which is going to be an integer, and it's going to be the amount of food, okay, and that's going to be in the processor. I don't want to type all that out. So amount of food in the processor. When we start off, it's at 0. Now, what we're going to be doing, and we're going to be also creating another integer called processed potatoes. Hopefully that's spelled correctly. It doesn't really matter. Okay, so we processed that many tomatoes. We processed 0 tomatoes, or we're on the 0th tomato. Okay, if the processed potatoes equals n. Okay, so meaning we've processed all the tomatoes, we're good to go. And we're actually going to use a while loop here. While we've processed, or we have not processed all the tomatoes, and we can fit more in there. So the amount of food is less than, amount of food plus, can we put another potato in? Amount of food plus an input of processed potatoes. Okay, so if we add that in, if it's less than or equal to h, meaning that's how much food it can hold, we need to add more potatoes. I'm sorry, and because we're just loading all the potatoes up as we can, so that's what we're going to be doing. So the way we do this is we do amount of food plus equals the input of processed potatoes. I keep on reversing that. I just spell that wrong. Copy, paste. Oop. And then we're going to add 1 to the potatoes, so this way we're not adding the same potato over and over and over again. So once we're here, we're going to be processing as many potatoes as we can. I'm so sorry about that. So we're going to be processing as many as we can. So, and I need to create a long call to answer. So let's take a look at what we're going to be trying to return. Print a signature of the number of seconds required to smash all the potatoes following the process. Okay, so this is actually very, very important. Okay, so what we're going to be doing here is we need to keep on processing all of our stuff. Now, I've simulated this, and again, we got the wrong answer. Or not the wrong answer, time limited. But, so the way you have to do this is using division. So once we have as much as we can, we need to keep on taking a look at adding stuff in. So we're at while processed does not equal n. Okay. So while we still have more potatoes to add, we're going to keep on looping through. So the first thing that we need to do is we need to see how many times do we need to eliminate or use the press, or how many seconds do we need to process that much food in order do we have enough space to add another potato. So the way that we're going to be doing this is we're going to check to see how much space do we actually need. So the way we're going to do this is, in order to find how much space we need, needed space is going to be just the input of the processed potato. And this is just getting too long. I'm just going to copy and paste it again. Processed potatoes. Boom. Now, that's how much needed space. But how much space do I have available? So, or how many times do I need to actually make this go? So, the way that we're going to be doing this is we need to take a look at the free space. So, the way we figure this out is the free space we have is K, I lie, it's going to be H, which is the height of it, minus the amount of food. Okay, so now we have the free space, so if there was like 4 units left and we were processing 2, and we need 6, that will be adding more in. So, but how many seconds do we need to process this in order for us to get the needed free space? All right, so we have the, man, I totally forgot what I did. I'm going to cheat. So give me 1 second, I'm so sorry. I have the free space, and then I have my needed free space. So it would be the item minus the free space. My bad. So we have the free space, the needed free. So I'm sorry, let me refresh this. I'm so sorry that I messed this up. I probably won't edit this. So we have the free space that we generated. So that's exactly what we did before. So we take how much can it hold, how much do we have, how much is empty in it. So how much more do we need to empty it out? Okay, so the needed space is going to be equal to the item input process item minus the free space, because we already have that. So if we need 6 units in there and we already have 4, so the only needed space is 2. Makes sense. So because we know that, we now can figure out how many seconds we need to work on this. So we're going to do time, and the time that we need for this is the needed space divided by K. But this will always round down because they're 2 integers. That's not good. We actually want to round this up all the time. So we're going to do a ceiling, and we want to use real division, not integer division. So we're going to cast 1 to a double. Now for this, we can actually cast it back to an int. Okay, because we're going to be always rounding up. Okay. Is that what I ended up doing, by the way? Oh, I just added it to answer. Okay. Okay. Anyway, that's how much time I'm going to be needing. And actually, that's probably a good idea behind it. If you notice right here, I ended up just adding the value to my answer, and then I've ended up subtracting it to the space. So that's actually a pretty good way of doing it. So let's actually do it that way. So we're going to take our answer, and we're going to add it to the values here. Why did that end up becoming, why was that okay? Because answer was a long. Huh, interesting. Did I still get an error? Interesting. All right, so now that I added that to the answer, that's how many seconds the processor is going to need to run in order for us to crush enough to be able to put another potato in. Then we're going to subtract that amount from the food processor. So we're going to do the amount of food that's in the processor. We're going to subtract it from the same value. So we know how many seconds it's going to take, so which is double needed space divided by k times k. Now, the reason why we're doing times k is because we need to eventually add, that's how what's in math.ceil is actually the time. And k is how many units are we getting rid of per second. So that's a big deal there. So looking at that, and you're actually might be thinking, hey, why are we have a divide by k and a multiply by k? But what we're doing here is if we do, let's say k was 2 and needed space was 1, 1 divided by 2 is half, 0.5, and you round that up to 1. And then you do 1 times 2. So they don't really cancel out. They can cancel out if it's evenly divisible by k, but if it's not, we need to always be rounding up. So the answer is not going to always be the same. So the next part we're going to be doing is we do an if in here, or we need to add the potato in. So we should have enough free space in the potato. This is slightly different of how I've done it, so I could completely screw up this video if this doesn't work, but I'm pretty sure this will work. What we're going to do here is we're going to check to see if the amount of food is less than 0. If it is, the amount of food is equal to 0, so we don't go to negative food. And then what we're going to do is we are going to be adding in the potato. So we are going to add the potato in. So we're going to be doing, where is it? Amount of food plus equals input. Do I still have it pasted in here? Yes, I do. Processed amount, processed potatoes, and then I add 1 to that. So eventually I will hit the limit. The last thing I need to do is once we've processed all the process all of them, they're all in the machine. But what would happen is we still have stuff in the machine. We still need to process it through. So we're no longer going to be doing the while loop. So we can make this go faster by just using our division. So we're just going to take this, paste it here. But all we really need to know is, I didn't want to do that. Copy. Is we really want the amount of food. Cast it as a double with our answer. So let's see if this works. I'm not 100% it will, because things have not been working very well for me lately. So let's try this out. Let's go to B so we can test our data out. And we're going to copy it. Run this. Boom. Paste. That was equal to 5. Is that 5? Boom, it worked. There. Let's take a look at this one. And does it work? 10. Perfect. And then we'll check the very last one. This one should be 2. 2. Great. So now we're going to copy and paste this in. Copy. And then we're going to submit our code. And let's see how this works. Does it work? Cross our fingers. Ooh. Look, 14, 45, and 48. Is it going to keep on going? Go, go, go. 49. It's getting kind of slow. This made me really nervous during the actual contest for getting time limit exceeded on this particular one. I'll be very embarrassed if it hits time limit exceeded on this one. So maybe it just froze. Let's refresh this page. Nope. It's going to run. It's going to keep on running. While we're waiting for it to run, the reason why I resubmitted it and it says skipped is I never ended up finishing it, or it wasn't accepted. But there's a problem. The big problem is I had this answer as saved as an integer, but when you do that, you get an overflow error. And unfortunately, these are just test cases. They all worked. Oh, yay, accepted. But there are problems in there where you can go higher than the value of an integer, which is not very good. So I did take advantage of that. In fact, in this particular contest, I ended up writing a program or not, that generated some output for me. And I can't see my hacks, can I? If I go to the room, I can. Yeah, so I ended up going through and made a couple people's showed people their error in their ways, and I ended up getting 5 hacks on these different people towards the end of the contest. Now, some people say, "Oh, that's horrible! You hacked somebody else's piece of code." Well, in CodeForces, it's actually you would rather be hacked than get the wrong answer because the very first person I ended up hacking, he or she had 14 minutes to make a correction to that particular piece of code and resubmit and get some points. So I really helped them to determine that there's a problem with their particular code. So that's really not that big of a deal in terms of hacking. Now, it does help my score out quite a bit. So I was kind of thankful that that solution was okay, because if you take a look, I went from submitting this particular problem at 26 minutes, getting a lot more points, than an hour and 15 minutes later, I ended up saying, "Oh no, I have to change a 3-letter word to a 4-letter word," and luckily nobody caught that to hack me. So I'm very thankful for that. I'm thankful that I ended up going back and reviewing what I did. So that's that. There's a common misconception on that, or a problem on that particular one. If you take a look, this is actually one of the people I ended up hacking. So he did go back and actually got these points. The test data, he would actually be missing these 490 points if I did not do it. So it does help him overall. So yeah, but unfortunately, like this guy right here, I think this guy was hacked, and then he could never figure out why it was wrong. So unfortunately, that was the way it was. This video went a little longer than I thought. I did not expect a 22-minute video, but thank you guys for watching, especially if you got to this particular point, and have a great night. So I will be uploading part 3 very shortly. Thank you guys, and have a great day.